Today we're going to use our calculator in using trig functions, and we're going to solve different pieces of a triangle. So let's start off with our first example here. I'd ask you to find the value of a trig function. Let's remember our SOHCAHTOA. So if I'm given a picture like this, again, the big deal here is you must look at the angle that you are referring to, as far as this asks us to find the values of tangent or of theta. So this leg is the opposite leg, this leg is the adjacent leg, and the hypotenuse would be 11. So to find the trig functions, all we do is take our SOHCAHTOA again. So we'd have 5/11. Cosine, we would take 4 square roots of 6. Why? Because that's my adjacent leg over 11. And to find the tangent, we take the opposite leg, which is 5 over 4 square roots of 6. Then if we want to find 6 of these, remember we flip. So again, we just flip. And these are the reciprocal functions. And there's not really a SOHCAHTOA for these, but you'll just take your sine, cosine, and tangent and then flip those values. The next thing is a calculator question. So if you will grab your calculator, there's a couple things that I want to show you on your calculator that are a little different. When you're asked to find a trig value using your calculators and rounding to the nearest, in this case 10,000ths, remember we'll round to tenths, hundredths, thousandths, 10,000ths would be 4 decimal places. So turn your calculator on, and when you turn your calculator on, when you're using the calculator for trig functions, for the ACT, you'll want to make sure that you are in the degree mode. So the first thing you want to do is hit mode and then make sure the degree is black. That's the first thing you want to do. The second thing you want to do is just punch. So if I've got 60, sine of 60, we just punch sine of 60. Remember, we're going to want to round to 4 decimal places. So the 2 is less than 5, so it would just be 0.660. If we want to find the tangent, that's easy. Again, just hit the tangent of 65. We'll get a value, round to 4 decimal places. We'll have 1, 2, 3, 4. The number next to that is less than 5, so it would just be 2.1445. Now what's a little trickier is if you try to find the reciprocal function. Notice on our calculator we just have sine, cosine, and tangent. And how are we going to find the secant or the reciprocal functions? Well, what does reciprocal function mean? Reciprocal means 1 over. So if we want to find the secant, we're going to, on our calculator, we're going to punch, make sure you write this down, 1 divided by the cosine of 60. And why cosine? Because remember, cosine goes with secant. So we'll still just get a ratio, but we have to punch 1 divided by cosine of 60. Think about 4 decimal places. Oh, there we would just get 2. Okay. Reciprocal functions, if we have, let's change this to, instead of finding the secant, let's go change and find the cotangent of 13 degrees. So if we take the cotangent of 13 degrees, the cotangent goes with tangent. So on our calculator we can do it, but we'll punch 1 divided by tangent. And again, round to 4 decimal places. Now you've had a little bit of experience with finding trig values, and the question might come up, well, why would I ever need to use these. And we'll use trig function to solve for triangles, and that's what our next problem is going to be. So if you're careful in looking at this triangle, copy this triangle down right. We want to find the missing side. So we want to find x. And using the words opposite and adjacent hypotenuse, this x would be referred to as the hypotenuse leg. Using the words opposite and adjacent hypotenuse, the 14 would be the opposite leg. So when we're trying to use trig, what we have to do is go back to our SOHCAHTOA, and let's look at what we want to find. We want to find the hypotenuse. So we're going to either use the sine function or the cosine function, because those are the only two trig functions that have the hypotenuse in it. And we look a little further, and in our picture we have the opposite leg. So we know that we're going to want to use the sine function because that's the one that has opposite and hypotenuse in it. So the sine of angle A, which happens to be 17.9, equals opposite, which is 14, all over hypotenuse, which is x. And what we have to do now is solve for x. So if we think of this as a ratio problem, what we're going to do is we're just going to cross multiply. And when we cross multiply, we'll get x times the sine of 17.9 equals 14. And further, if we solve for x, we're going to divide both sides by sine of 17.9. And that's where we're going to use our calculator. And that will give us the value of x. So again, write down all these steps, because when I punch in their calculator, you'll understand where these numbers are coming from. So I'm going to, again, I have to make sure that I'm in degree mode. I still am. So this x was equal to 14 divided by the sine of 17.9. And the hypotenuse should be 45. Now, when you look at this, that's quite a bit bigger than this opposite leg. But remember, this is across from a 90-degree angle. So that should make sense that the hypotenuse will always be the largest side. And that's how we'll use these trig functions to solve for triangles. This next example, again, let's look at the sides we're given. We're given the opposite leg and the adjacent leg. So looking at our SOHCAHTOA, we want to find the trig function that has opposite and adjacent to it. That's the tangent equals what? Opposite over adjacent. We cross multiply. And this time it's just 6 times the tangent of 34 equals 1 times x is just x. So now this is just a straight punch on our calculator. And so if I punch 6 times the tangent of 34, this should give us x's value is 4.0. And that should make some sense because this leg should be small.